Today at the House of Hacks, we're going to unbox and set up this Labast's Raspberry Pi starter kit. Okay, the box it comes in is nice and sturdy. Not much to it, just kind of your basic box. We'll go ahead and open this up. It's got a couple anti-tamper stickers on it, and we'll just open this up. Recently, I've had some ideas floating around my head for some projects where it needed a little bit more computing power than what an Arduino supplies, but I still want to be fairly close to the hardware. So of course, the Raspberry Pi is a great solution for this. Having never worked with Raspberry Pis before, I didn't have anything, and I wanted a starter kit just to get going quickly. So I searched on Amazon and found this Labast's starter kit. It came with pretty high reviews and seemed to be pretty complete. So I went ahead and got one. It's supposed to have a case and power supply and other miscellaneous things that you need to get started. It doesn't have a keyboard or monitor, of course, but I have those in plenty. So I went ahead and got one of these. It has 8 GB of RAM and 128 gig SD card. And so I thought I'd open this up and show you what it takes to get started. If we're just meeting, I'm Harley. Welcome. This is the House of Hacks, where I make stuff, usually out of metal or wood, other kinds of media like that. Sometimes it includes things like Arduinos and Raspberry Pis. It starts off with this Raspberry Pi Model B, 8 gig of RAM. That looks like the main box, or the main computer. Rip the box, and there's the Pi. They are pretty small little units, aren't they? Has the connectors on the side, the power supply, network, USB, looks like USB 2 and 3 there. And yeah, there's not much to it. Not much bigger than a Arduino. Just for size comparisons, there's an Arduino Uno. It's a little bit bigger, but about the same size. Digging more into the box, packing material. Oh, and then inside this box, looks like there's some basic instructions and a fairly large piece of paper with multiple language instructions. We've got a quick start guide. A power supply with an on-off switch. Labast's power supply. We have, looks like a case. I assume it kind of snaps open somehow. I won't do that here on camera, but it's got the holes for the connectors. It must go this way. There's the connectors that way and that way. And interestingly, it looks like it has a 1/4-20 connector on there, which I'm guessing they may have it set up for putting a camera on this. It kind of looks like a camera hole. Don't know exactly. Looks like a hole for a lens on a camera. Might have an above board camera you could put on there, and then that would be for taking pictures with. Interesting little concept. HDMI cable. This looks like another HDMI cable. That's definitely HDMI. That's definitely HDMI. So 2 HDMI cables. Cute little tiny fan. assume that goes in the case. An SD card. It says Raspbian on it, so I assume it's preloaded with the operating system. That's handy. I don't recognize that. I'll have to read the manual for that one. A little screwdriver for mounting the fan. Some heat sinks. And that's it. So, everything that comes in the box. Those are the things that are inside the box in this kit. I want to get into the setup of this and see what happens when we turn around for the first time, but before that I do have an exciting announcement. Those of you that have been around the channel for a while may have noticed that my uploads this year have been down than they have from previous years. That's not because I've been slacking off, but because I've been working on a new project. This is a beginner's guide to working with electronics, specifically the Arduino ecosystem. So if you've been interested in getting Arduinos into your projects but don't know anywhere to begin, this book is for you. I talk about three things in it. Basic electronics. What is a transistor? What is a resistor? Real basic things like that. And then I talk about how to set up a computer to program on Arduino. And third, I talk about the basic elements of what goes into an Arduino program and the fundamental programming issues related to that. If this is something that sounds interesting to you, I've left a link down below for a mailing list where I'll be announcing when the book is released and also providing a discount code for those that are interested. Now that we got everything unpacked, let's assemble this. The quick start guide is fairly thick and a bit intimidating at first glance, but there's 6 languages in here. So for any one language, there's only about 4 pages. Half of those 4 pages are how to install operating system on a blank SD card. The SD card that comes with this is already pre-formatted, so we don't need to worry about those 2 pages. About half of the rest is specifications and what comes in the kit. So there's really only about a page and a half of actual instructions for getting started, and those seem to be really clear in reading things over. I don't have any questions off the top of my head. We'll see how complete they are once we get into it and see if we have any questions. The mystery piece that I wasn't sure when I was unboxing it is actually an SD card reader, which is kind of handy. It's a Type-C connector. It pulls apart, and there's the connector for plugging into USB, and there's where the SD card goes in on the back side. So that's kind of cute. It's inexpensive one. It's not great, but I'm sure it works for the purposes that we have here today. There's really only a couple steps we need to do. We need to install the heat sinks onto the card. We need to install the fan into the case, and then we need to install the card into the case and put it all together. Finally, we can install the SD card after the card is in the case, and then apply power and keyboard and monitor and see how it works. They do say that you don't want to have the SD card in the computer when you're trying to put it in the case. I think there's a fitment problem with getting it all lined up and stuff. So you put the card in after everything is assembled and put together. So let's get to this. First, we're going to put the heat sinks on the chips, and the manual says exactly which ones they go onto, and they are self-adhesive, so they should go on fairly easily. We've got this one goes on that chip. We've got this square one that goes on the main CPU, and then we have this other smaller one that goes on, looks like the chip that's right there. So that's how it's assembled. Time to get out the tools. I've got a pick that works really well for taking off things like self-adhesive tape when it's hard to get off. That one wasn't too bad. So that goes on. Try to get my fat fingers in here on this little board. That goes on that chip. Just press that on. This self-adhesive tape isn't too bad to take apart. Sometimes it can be a real pain. That goes on that chip. And this goes on the last one. That, I assume, is the primary CPU. It's this metal cased one. That was easily done, and I didn't need the pick at all. So now we want to install things in the case. The case just pulls apart. There's a little handle there. And there's screws for the mounting the board, and there's screws for mounting the fan. Seems like there's more screws there than I actually need. And this case also is designed for a camera. I didn't get the camera option, but there is a hole in the case and mounting space to snap a camera in there. The fan can go in two ways. There's no indication of airflow. I don't know that it really makes a difference which way it goes in. Put it in this way so that the strain relief on the cable pulls up when you're... The self-tapping screws go into the fan. They have a round head on the top. They're a bit longer than the screws in the other package that are for the card. You don't want to torque them down too tight, since you may strip out the plastic. So you just need to make them so it holds things in without rattling. And that's the fan in there. Next we need to mount the board. It's pretty obvious. There's big holes in the case, go for the USB and Ethernet card. And this should just drop in there, and there are, seems to fit fairly snugly. There we go. You can kind of feel it where it snaps in. You want to make sure that the connectors are all lined up with the holes, and the connectors on the side actually kind of fit into the holes on here, so it has a bit of a snap feel to it. Get the other screws. These screws I'm going to need the spectacles for. It'd be nice if this screwdriver was magnetic, but that one went in without too much difficulty. On screws like this, I tend to start them, get them all started, and then I go through later and second pass and tighten them down for good. That way you don't, if you tighten it down one at a time, sometimes you'll knock things out of alignment, and then it's harder to get the other screws in. And for both sets of screws, they sent me one screw more than I actually needed, which was convenient since I had dropped one of those on the floor. I'll have to go retrieve that later. And now I can go through a second time and tighten everything down. Again, you don't want to tighten it down too tight because you don't want to strip the threads or the head. And this screwdriver seems to be possibly at about end of days. This one screw, no, this one screw has some munged up threads. Screwdriver is fine, the head is rounded out without putting any torque on that at all. And I can't get it out, so I need to get the pliers. Let's try the extra screw that they gave me. Those are magnetized, and it's making it hard to get the screws in. Once you have threads in plastic, you want to do a technique called indexing, where you turn backwards until you feel a click, and then you can go forwards again. That way you're not cutting new threads into the plastic. And this new screw worked much better. There we go. So I think now we are ready to put the operating system SD card into the case. And there's a small slot right there in the back of the case that this should slide into. Just like so. And yeah, it protrudes out. So if that was in the card, when we tried to put the card in here, we'd have problems getting it in. So that's definitely what's going on there. And now we're ready to wire up the fan. The fan goes in this way. And there's two options on this. So there's the red wire is positive and the black wire is negative. And the manual says which ones go where, with some pretty detailed instructions. There are two options on this fan. You can either run it at low speed on 3.3 or at high speed on 5 volts, both of which are available right here on the GPIO connector. And the black one is ground, and it's on pin 6, which it shows right there. We orient this in the way it shows in the diagram. Pin 6 is the third one on the top. So it goes in there. And then the red is either pin 1 for 3.3 or pin 2 for 5 volts. So I'm going to put it on 5 volts because, hey, more power, right? And then everything should just snap back together if I can figure out which way this goes around. And there we have it. We're ready for power, keyboard, and video. So we have the things that came with the kit and a few extra items in order to use this. We need an external monitor. This is a small HDMI monitor that is designed for use with video equipment, but any HDMI output source will work. I also have a keyboard and a mouse. Those are really the only things you need in addition to what comes in the kit. For the purposes of today and this particular setup, I also have an HDMI splitter so that I can run the signal out of the Raspberry Pi not only to the monitor, but also into my computer to be able to record it and capture it in high quality so that you can see what's going on in the video. That complicates this particular setup, but that's not a setup that you normally need when working with the Raspberry Pi. One thing of note is, while the power supply that comes with an Arduino looks like a normal wall wart, it is a high power device. The Arduino requires more than what most wall warts produce. Most wall warts output in the milliamp to maybe 1.5 amp range. The Arduino needs more than that, and this particular one that came with this kit is a 3000 milliamp or 3 amp power supply. So you do want to make sure that if you're not using a kit, that you get a power supply that has sufficient output for the Arduino's use. If you don't have a power supply that has enough power, you'll get weird things happening. It'll work sometimes and not others. It will just work for a while and then suddenly not work, just kind of bizarre things like that. So if you do have problems like that and you don't have a power supply that came with a kit, make sure that the output of the power supply is sufficient for the Raspberry Pi. Let's start putting this together. Everything's plugged in now, including the power supply into the wall. I've got the software running on the computer to capture the screen. I'm using OBS, by the way, just to record everything. It's open broadcast software, I believe is what it's called, and we're just using it as screen capture at this point. Off the HDMI input and the little converter thingy that I have. And yeah, let's turn it on and see what happens. Down here in the corner, I've overlaid a time code on the screen capture. I'll be speeding up through parts of this so we don't have to wait during the entire video. The time code will show the actual length of time it took in real life. It takes a bit to start up, and now we have a background with this welcome message. I'm going to go ahead and hit next. And now we get a chance to set up our country, language, and time zones. I'll set mine for the United States, and since I'm on Mountain Time, I'll select Boise. Clicking next, it takes a couple seconds to set that, and now we have the opportunity to set the password for the main account. I'll put that in here, what I want to use, and click next again. Now it's asking about screen setup. We can see around the outside edges here that we have a black border, where the background screen doesn't take up the whole screen. This has to do with different HDMI display devices, and sometimes you'll see these bars and sometimes you won't. Since we see them here, I'm going to click this checkbox, and that should remove them in the future. So now I'll click next to save this. And the next step is it's looking for wireless networks. We can see a bunch from the neighborhood here, so I'll scroll down here and select mine. And it refreshes the list, and now I'll have to select it again and hit next. And now it's asking for my wireless network's password, so I'll put that in and continue on. And now it wants to update the software. I'm going to click next, and for some reason it didn't connect to the network. I'll have to look into that, but for now we'll just move along. That's something that I can do in the future. And I guess that's it for the setup wizard. It's going to reboot, and let's see what happens. Okay, that didn't take too long. Now we can see the whole screen is being used. We don't have the black borders, so that worked. And in the top right corner here, we can see that we now have a network connection. So now let's go look at the software installer. I'll go over here to the menu and click on the Raspberry Pi icon to pull the menu down, and then I'll go down here into Preferences. Let's start with this recommended software option, and it'll start off by checking for updates. So it's going out to the network and seeing what's different between what's been released now and what the software was originally set up for. Well, that took about a minute. Now we can see all the menu items that are part of the recommended list for the Raspberry Pi ecosystem. On the left, we have different categories, and when you select one, it shows the items in that list. You can check or uncheck the box on the far right to add or remove the options that you want installed on your particular Raspberry Pi. And after you have everything you want selected, you click Apply, and it'll start installing or removing as you've directed. This may take a bit depending on what you've selected and the speed of your internet connection. Fortunately, it does a good job of telling you what it's doing with all the status messages and the progress bars. After it's gone through and figured everything out, we get this completion dialog when it finishes. If I hit Apply again, we'll see that nothing happens. It's all caught up. So I hit Close to finish this step. And so now here, if we look in the menus, we can see that that installed the software that we asked for. Now I want to make sure that the operating system is up to date. To do that, I'm going to go to the terminal window and run a command. Sudo apt update will check for updates for everything that's installed in the Pi, both at the base operating system level as well as any additional installed applications. It takes a little bit, but generally not terribly long. When it finishes, we get back to the command prompt. All this has really done is update some internal lists so that it knows what needs to be updated. It hasn't actually done any updates. To do the actual update, I'm going to run the command sudo apt full-update. This will compare what I have installed to the update list and tell me what needs to be changed. I have the option to continue or not. Hitting return selects the default yes answer that's indicated by the capital Y, and off it goes. This does take a while. It's a two-step process. First, it has to download all the actual items that it needs to install, and then it has to actually install them. Again, it does provide good feedback while it's doing this, but it may take some time depending on how much needs to be changed and the speed of your internet. In this situation, it took between 7 and 8 minutes that I've sped up through here. Now that the updating is all done, I want to see how much storage space I have available for future development. I'm going to use the df command with the -h option. On the first line, it's showing that I have 3.1 gig used and 110 gig is available. That's out of a 128 gig SD card. So that's not doing too bad. There is some overhead for the operating system, of course, and things like that. The update process downloaded a bunch of files that really aren't needed anymore. To clean those up, I'm going to use a sudo apt clean command. That doesn't take any time to run, it just returns immediately. Running the df-h command again shows that now I have 3.1 gig used, freeing up about 100 megabytes. Not a whole lot, but every little bit counts. Now I'm done setting this up, and so we're going to use the exit command to close the terminal. All told, that took around 19 minutes to do the initial setup, and now the Raspberry Pi is ready to be used. For now, I'm going to shut it down by selecting Logout and then clicking Shutdown. You always want to make sure you do this when you shut down, just so that everything gets written out to the SD card properly. Do you have a Raspberry Pi now? Or are you thinking about getting one? What are your plans for it? Leave a comment down below and let me know. I'd love to hear about it. I'll see you in this video over here that YouTube thinks you're going to enjoy, and when making things, remember, perfection's not required, fun is.